Turning on your computer remotely can be achieved in a few different ways. You can use Wake on LAN, a KVM, or some silly-looking remote starters found on AliExpress. However, you might be able to build something similar with parts you already have. Not only will this project allow you to turn on your computer over Wi-Fi, it will also log you in automatically. This project is built around the Raspberry Pi Pico W. What's great about the Pico is that it runs CircuitPython and allows for USB HID emulation. This means you can send keyboard and mouse inputs, much like a rubber ducky. And with the wireless chip on board, we can utilize MQTT, which is a messaging protocol commonly used in IoT devices. To actually turn on the PC, we're going to use a transistor to simulate pressing the power button, but the case power button will also be functional. Let's look at how all these elements come together. We have the transistor base connected to one of the GPIO pins on the Pico, and the collector and emitter pins are connected to a pair of leads that go to the power switch pins on the motherboard. Note that the emitter is also pulled to ground through a 100 ohm resistor. That's necessary for reasons, I guess. Quite honestly, I only sort of know how transistors work. Perhaps someone could explain why we need it. We add a pair of 90-degree male header pins to which the case power button will attach. Finally, we need a couple of wires coming off that will go to the motherboard power pins. And that's really as complicated as the wiring gets for this project. We are going to attach a small tactile button to the Pico connected between GPIO pin 16 and ground, and that will serve an important function later. At this point, you may be wondering how we're going to get power and USB data to the Pico when it's inside the case. We can use the USB headers on the motherboard to accomplish this. The JUSB headers are the same as regular USB cables, just with a different connector. We can make our own wire with female header pins and wire that to the Pi. I made the extra effort of melting one of the holes to key my connector so that it doesn't get plugged in upside down. As for the other end, we can wire 5 volts to VBus, ground to ground, but where did the data pins go? Turns out, on the underside of the Pico, there are a few test points labeled TP1, TP2, and TP3. TP2 and 3 are actually connected to the data pins on the USB, so we can solder right to them. TP2 corresponds to D negative, and TP3 corresponds to D positive. But I would actually recommend against this, however. The test point connections are very fragile, and I frequently lost connection. I also ended up having my data pins flipped, even though I was sure I had them correct. So I ended up soldering a micro USB cable to the female header. Or alternatively, you could just buy one. I didn't realize that this product existed before I figured all this out, but in my defense, I didn't know what the JUSB side was called for a while. And the lengths come in pretty long lengths. So just go with the micro USB to JUSB cable. I added a few header pins to attach the Pi to the perf board, and that should be all the soldering done. I'm glossing over a lot of the soldering process. If you want to do this yourself, all you need to do is follow the wiring diagram I've made. I would strongly recommend insulating the bottom of the board with electrical tape or a 3D printed case. Now, let's take a brief look at the code. To start, you will need to install CircuitPython on the Pico. There will be a tutorial linked below. You will also need the MQTT and USB HID libraries, again linked. The code.py file is run when the Pico is powered on. I'll just point out a few things here. One is that we're utilizing the secrets library. This allows you to store sensitive information in another file, so you can share your code without sharing the info. If you try this project, you should only need to update the secrets.py file. The code starts with setting up the Wi-Fi, MQTT, HID object, and pins we'll be using. I'll assume that you already have an MQTT broker set up. We define callback functions to run when we receive a message on the topic we are subscribed to. If we receive the correct message, we do a short press, which activates the transistor for just a second. Wait some amount of time for the computer to reach the login screen, and then it types the password and hits enter. Simple. Now you might have noticed that the secrets file has all of our Wi-Fi, MQTT, and computer passwords easily accessible in plain text. Uh-oh. This is where the button we attached earlier comes in. We can modify the boot.py file to disable USB mass storage if the button is not pressed. That way, it's at least a little bit more difficult for someone to read your passwords. I recommend you test and ensure everything is working before you uncomment the code. And that's pretty much it. From here you can send MQTT messages to the Pico from your phone, or connect it up to Home Assistant and add it to automations. I hope this is useful for someone. I'll probably fix up some of the issues with mine, and if they're notable enough, I'll make an update. There's also potential for making a tidy little PCB that turns the thing into a little stick of gum that turns on your computer. Let me know if you'd be interested in that. Thank you, AliExpress seller. God bless you.